What's up? Welcome back. In this episode, we're doing day 5 of the Advent of Code for 2023. We're going to talk a lot about ranges, and man, this one was a doozy. This was tough. This was super tough. So this one's called If You Give a Seed a Fertilizer. It's if you give a mouse a cookie type situation. We have met a gardener who is helping us out, and the gardener has an almanac, and they're having trouble making sense of this almanac. And I trust that most people who encountered this also had trouble making sense of it. Okay, let's walk through what we've got here. The top is a list of seeds. And in part 1, each of these seeds is an individual number that we're going to count as a seed. Then we have a bunch of these maps. Now, the way that the maps work is they converting a seed number into a soil number. So we are looking for how to convert that. So our source category is in the middle, our destination category is on the left, and then the number on the far right is how far those ranges extend. So in this case, because we have a 2 for the length of the range, our source goes from 98 to 99, and our destination goes from 50 to 51. And we need to figure out, like, if we're given a seed that is 98, it needs to map to a soil number that is equal to 50. Similarly here, our source starts at 50 and then it goes 48 numbers. So 50, 51, 52, 53, all the way up to 98. And those numbers map to 52, 53, 54, all the way up to 100. We need to figure out how to map from a seed all the way down to a location. When I first saw this, I thought, oh, this is going to be super cool because we can use zip. So we could convert 98 into a range of 98, this plus this many, and 50 into a range of 50 plus this many. And then we could zip the two of them together and build a hash where we have a number on the left that points to a number on the right. And then we could build up several of these different hashes, traverse all of these dictionaries, and get our number. And then I looked at your puzzle input. The puzzle input for today is these insanely massive numbers and the ranges that we're working with. Remember that the number on the far right, this is the length of the range. So for our source number here, which looks like 3 billion something plus 7 million something, right? So if we were to do that with a dictionary, we would end up just with these huge, massive, dense dictionaries of numbers. And so that's not going to work. So we've got to figure out a more efficient way to do that. So let's get started with this first part. In part 1, we want to find the lowest location number that corresponds to any of these initial seeds. So any of the initial seeds that are passed in, we want to find what is the lowest location number that we can map to. In the case of seed 79, it ends up with location 82. Let's make our first goal just see if we can get from seed 79 to soil 81 with this input here. So we've also got to do a bunch of parsing and some other stuff. All right, so let's at least get this parsed into a format that we think will work well for us. So let's open up main.rb here. We'll drop in our input. We have this seeds business at the top, and that's going to give us some numbers that we want to work with. And then the rest are separated by an extra new line. So let's start by grabbing off our seeds. So we'll say input.split on 2 new lines. And that should give us back our seeds line and then the rest of the lines. P seeds, main Ruby, RP. Okay, so then we're going to say seeds is equal to seeds.split on, we can just split it and then dot map to I, and we can ignore the first one and bundle up the second one, or like the rest of it. And we should get this array of numbers. Does that not work? Oh, seeds.split dot map to I. Okay, so now we have 79, 14, 55. Cool, so that gives us our seeds. Now let's work on the rest of these lines. So now if we look at lines, what is that? Okay, seed to soil map, and then these are all going to give us these rows of things for each. I guess this is like a groups. So we will say groups is equal to groups.map, and then we want to split on new line. The first one is going to be the label, and then the rest is like these mappings that we actually care about. And we want to go through each mapping. Okay, and let's print out groups to see what we get back. All right, so our groups look like this. So one group has the array of 50, 98, and 2, 50, 98, and 2. And again, looking back at our goal here is we want to get from 79 to soil number 81. If we look at the difference between the source and the destination, we get like this offset. Let's reorganize this to also have, we have the destination, we have the source, and then we have some length. And what I think we want is we want the source plus the length, and we want the destination minus the source to give us like some delta. So we want to take 50 minus 98 to know how far we need to shift from seed to soil when we encounter this mapping here. So this ds minus source should give us the destination to source delta, right? Okay, so now let's p groups. Okay, so now we have 98, 100. So if our seed is between 98 and 100, then we need to apply this delta to it to get out the soil version of that. Same, if it's between 50 and 98, we need to apply this delta to get the soil version of that. So now what I think we can do is let's just try with one seed. And I'm also wondering if we want to just convert this into a range right now. So if we run this, then our first element is a range from 98 to 100, and it tells us the delta. And what that does is it makes it so that when we iterate over each of these groups, we can find, we should be able to find which groups are applicable to our given seeds. So if we say that seed is 79, we need to go through groups 0 because we only care about the first group, which is the seed to soil group. And for each of those, we want to see if that group range includes the seed. So if the group range includes the seed, then we want to, if the group range includes the seed, then we want to apply seed plus, plus offset. That's what we want to like kind of print out. And then we'll break. So let's just see. So we get back 81. Okay. So 81 is the delta, or I'm sorry, 81 is the soil number for seed number 79. Does this work for 14? Let's see, 14. It does not. So we got no output for 14. One of the other things that I forgot to mention was that if there is a range that is not covered by the mapping explicitly, then we assume the delta between the two is 0, and that it's a direct mapping between the input and the output. So when we're looking at this seed to soil here, there's an invisible one that goes with the source is 0, and the destination start is 0, and the length is up to, but not including the next, like the first range. So this would go like 49, I think. And then similarly, there is a range that goes from the highest source all the way to like infinity. So in this case, it's like 100, or this would start at 100, 100, and it would go like infinity. So there's like a start cap and an end cap to each of these ranges. So we need to add those in. So we can do that by injecting something here. Within each mapping, we want to sort the list of these rows. So I think for now, yeah. Okay, sort by range. That should work. Let's see. 50 to 98, 0 to 15 to 52. Okay, so those are sorted. And then once they're sorted, okay. We want to look at the first element. Okay. The first element is the lowest range. And then we want to look at the first element of that and its begin. Okay, so if this does not equal 0, then we want to add in mappings.unshift from that up to begin with that. Now if we p mappings, yeah, so now that matches, okay. 0 to 50, 50 to 98, 98 to 100. All of those look good, and we have all of our zeros. Now what we want to do is add our end cap. So now we want to say mappings.push. Okay, let's just see if this worked as expected. Okay, so now we have one from 98 to 100, 100 to infinity, 52 to 54, 54 to infinity, 53, 11 to 53, 53 to 61, 61 to infinity. Okay, so now we should have good mappings. And when we iterate over each of the groups, we want to see if it's included in there. Okay, so now we got, for 14, what did we get back? We got back 14. For 14, yeah, its corresponding soil number is 14 because it's not covered by one of the ranges for seed to soil, right? So this should fall into the default range of 0 to 49, and the diff should be 0. So that looks good. So if we have a seed number of 55, the soil number should be 57. So let's add our seed number of 55. Expecting 57, we got 57, great. Okay, now that's working for seed to soil. Now we need to go from seed to location. And that means we have to go through soil, fertilizer, water, light, temperature, etc. So what we can do now is say, okay, so this was going through in individual groups stuff. So we want to say groups.each do group. And for each group, we want to iterate over and see if that group includes the seed. And if it does, print out the stuff. And we also need the output of that to be used as input into the next thing. We need to keep track of what the current seed is and update that here. So our seed starts, or our seed might start at 79. And as we check to see if it's included, then we want to update the seed to change its offset. So here we're going to say plus equals offset. And then that should, by the time we finish all the groups, if we print out seed at the bottom, we should get some answer. So in that case, it's 47. That is not what we're looking for. Okay. So what is going on here? For each group range, if the range includes the seed, increment the seed by the offset and break, right? Let's make a method here called find that's going to take in a group and a seed. And what we'll do is we'll say, yeah, we'll go through each of the combos in that group. And if we find the seed, then we increment the offset. Seed plus offset. Let's see. Okay, we've got 82, and that is our location, 82. Okay, so what's happening here is our find method, at least, is going through one single mapping of some measurement to some other measurement. And if it finds the range that includes the seed number that we passed in, then it's returning the seed plus the offset. So that gives us back our seed. So now what we need to do is do that for all seeds. To get to the next step is to find the lowest location number for all of the given seed inputs. So now we need to do seeds.each do seed. And then if we just want like a min seed, so we need to map over this and then pull off the min. And this should be our min seed, and we'll print min seed. And there we go, 35. Okay, yeah, we have to return it from the map. Okay, 35 was the answer, right? 35 was the answer for the lowest location given these seeds. Okay, now let's try it with all of our input. So now we'll just say input is equal to data.read, and then we'll paste in our puzzle input here to the bottom of our file. Okay, label isn't used. All right, so now we should be able to run this, and we get back 324,724, so blah, blah, blah. Let's see if that is our answer. Yep, looks like that was our puzzle answer for part 1. Okay, this is a little tricky, right? Because the way that we're finding, or we're like moving forward and progressing through each of the stages, like each of these mappings, is that we're getting some return value from each mapping. So the first time we call find, we are looking through seed to soil. The next time we call find, we're looking through soil to fertilizer. The next time we call find, fertilizer to water. And then inside of find, we're looking through, does it match our 0 to 0, 49, or does it match our 100 to infinity? Which of these ranges does it match? And depending on the range, we apply the offset defined by the difference between the source and destination. And we're looking for the lowest possible offset. Now, in this solution, it works fine with these big numbers, and it's like just looking for a handful of seeds, right? Like our input here, like the number of seeds that is in this line isn't that big. So we're probably looking at max like 25 different seeds. So we're able to iterate over 25 seeds and then iterate over all of these groups and all their rows. And this file only has 292 lines. So maybe 250 of those are, yeah, I guess like 220 of them are actually data. So there's not a ton of data here. It's just that these numbers are very big. So we have to be careful about the way that we choose our data structures and algorithms. All right, so that worked for a single seed. Now this is where things get a little hairy. In part 2, everyone's going to starve if you only plant such a small number of seeds. That's right, we can't just plant the 20 seeds or whatever that we were given at the beginning. Instead, what we have to do is we have to plant all the seeds. And by all the seeds, it means that our input here wasn't actually individual seeds. It was ranges of 79, 80, 81, 82, 83, 84, up 14. So the first digit is the start point. The second digit is how long the range is. So here we have 79 up to 92, and here we have 55 up to 67. So instead of just going by individual seeds, now we need to iterate over pairs of seeds. So this is going to change a little bit, right? So instead of just seeds.map, we need to do seeds.each slice of 2.map. And that's going to give us like a seed start and a length. So if we p out our seed start to seed start plus length, this is going to give us a new range. So let's take a look at what that range is. So we'll run this. Okay, so now we have a bunch of seed ranges. So each of these seed ranges becomes our new input. And what is the puzzle question here? So that's like how we modify the input, is that now seeds are all ranges. And rather than considering those 4 seed numbers in the beginning example, this now has 27 seed numbers. Using the example input, the lowest location number can be obtained from seed 82. Okay, so if we're looking at all of the seeds here, there's 27 total. So there's 14 on this range and there's 13 on this range. And the one that is the most, or has the lowest location number, spilled coffee. The one that has the lowest location number is in this range. It's number 80. And the location we get out of 82 is 46. 46 happens to be the lowest. What do we do? One thing you might think to do is to say, let's just iterate over all of the seeds in the range and then try to find the best one. And if we find it, then print out its minimum. But because we're working with such massive numbers, let's actually call this seed range. So if we do seed range.each do seed, and we try to find it, p seed, and we try to run this, look at that. It's just hanging. It's taking a super long time because the range is massive. We cannot just iterate over the range. Instead, we need to be a little bit creative about how we figure this out. We can't use a dictionary, and we can't we can't use a dictionary to fill out all of the content in between all these ranges. We can't iterate over the ranges. They're too big. So the approach that I took was to take each seed range. So you take each of these ranges, and then for each of the mappings, you break those ranges down into smaller ranges that have the offsets that are applied to each of those ranges. And then you pass those ranges as arguments forward down into the next mapping. Okay. So in the same way that here we're like looking at to see if the range includes the seed, we're going to do something similar, but instead of just returning the seed plus the offset, now we're going to return the seed range split up by the overlap or like the intersection of the ranges. I wrote a method here. I'm going to call it convert. And this is going to take in the page or like the same sort of group and some seed range. We want to see if any of the group ranges overlap with the seed range. If so, return the list of intersections with offsets. We're going to iterate over the group dot map. This is going to give us the group range. And we need to see if the group range overlaps with the seed range. Add that intersection to the list to return. Okay. So this is going to be ranges or something. I don't know. And that's what we're going to return. So if the group range overlaps the seed range, then add the group range intersect the seed range. Okay. And then instead here of seed, we are going to get back, yeah. Okay. So this is each of our seed ranges. Instead of getting a seed back, we're going to get some ranges. We're going to get some ranges back. And we need to pass in the seed range as the argument. Now we can print out ranges, and let's just see what that does. Okay. It turns out that overlaps is not a method on range, at least in default Ruby. There is a method called overlaps on range, but this is given to you by Rails, not by Ruby. So if we look at the source here, This is something that's provided by active support. So active support monkey patches or somehow adds in this overlaps method. So we're just going to grab that, open up range and add that in so that our range method supports overlap. All right, so let's see if this works now. Overlaps, undefined method overlaps for array. Okay, it should not be on array. It should be on the range. Okay, now we're getting another error, undefined method ampersand for range. It turns out that range also doesn't have an intersection method. There is a great blog post on copyprogramming.com on how to add the intersection of two ranges and support for it. There are a few different solutions here. Solution one, simple. I'm just going to grab this and pop it in, and this should work fine for our uses. And then this alias method thing makes it so that we can use the ampersand method instead of calling intersection. So this should work, I think. Undefined method or variable ranges on 96. Okay, ranges is equal to an empty array. Just increment that. Okay, let's run this with our example input. Max cannot exclude non-integer value end. Huh? Okay, maybe we should use one of these other ones. Okay. So now we're getting back a bunch of ranges, or at least we're printing out a bunch of ranges, but who knows if those are actually valuable, valid. You'll also notice that there's a bunch of repeating. So 55 to 67, 55 to 67, 55 to 60, 61, 55, 67. So this isn't actually doing what we want, right? This is collecting up all the ranges, but we need to keep track of which group we're in and which ranges apply to that group depending on the seed range that we're on, because we need to figure out like the optimal path through the different options. So instead of just having ranges for each of the seeds as we go through, what I think we want to do is create an array or a dictionary that helps us keep track of which group we're in and the ranges that are being considered for that group, because we can only pass soil into soil and fertilizer. We can only pass fertilizer into fertilizer and water. And right now what we're doing is just collecting up a bunch of ranges that are for the entire data set, which doesn't really make sense. So we need some array that's like, maybe this is ranges, but it's going to be something like array.new. And we're going to need an array of arrays where each, how many do we have? We need one for the initial set of seed ranges. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 elements in our array. And we're going to start, we'll say ranges at 0, and we want to add in the seed range. And then groups.each with index. And now we want to work with ranges at I plus 1, because that will be the results for the future range. And then here, what we're passing in should be ranges at I think. No, that's going to be an individual range. So maybe we need to iterate over, yeah, ranges at I dot each do range. And then we need to pass in that individual range. Whew. Okay, what is this even doing? All right, so for each seed now, we have a mapping. Okay, the very last element in the ranges array should be from our humidity to location thing. And we are expecting to get back, what? 46 as the lowest. Do we see a 46 in here? Hard to say. Let's just do ranges dot last dot, yeah. And then, okay, so we're getting back 55. That is incorrect. So somewhere here we have a mistake. Okay, let's simplify this. Let's simplify this a little bit by removing uh, two of these numbers here. And then let's print out ranges again and see what we get just for 79. So we're getting 79, 93, 79, 92, 92, 92, 92. It doesn't seem like we're actually shifting at all. Okay, so we have the intersection of our group range and our seed range here. What does this actually look like, this intersection? P intersection. And then we're assuming, yes, okay. So this is the intersection, which is 79 to 92. But what we want is to, oh gosh, we need to apply the diff. Okay, so the range that we want to add is the intersection dot begin, yeah, plus intersection dot end diff. Okay, bad value for range, begin. Bad value for range as the argument error. Is this... Let's just print out what this gives us. That should be, okay, so that should be 81 to 94. Why is that getting sad? Maybe it needs a thing around the entire, okay, here we go. All right, so now we have 79 to 93, 81 to 94, 81 to 94, 81 to 94, 87. Okay, now we're getting closer to having something that is the numbers that we need, right? Which is, okay. So I think we're close. I think we're close. Okay, so ranges dot last dot map begin min. Okay, 46. All right. Oh gosh. Okay, and then can we switch it to use our real input? That doesn't look right. Shouldn't be a giant thing. Why are we scratching my head? We don't see min. Oh, maybe it's still working. It's working on something. Okay. Okay, let's stop that. One of the things that I noticed again, like when we're looking through these things, let's print out ranges again. Okay, so we see 79 to 93, 55 to 68. In here, we have 81 to 94, 81 to 94, 81 to 94. So when we're in the group, when we're in 0, 1, 2, when we're in group 2, we're already starting to have a bunch of repeats between ranges. And I'm sure that's exploding as we build out the complexity of these other things. So instead of having an array here, let's make this a set so that we have a unique element there. Let's see. Ranges. Okay, so p ranges dot last. I think maybe let's see if that works. Okay, so we still get 46 there. Does that make it fast enough to work for our actual input? Boom. All right. 104070. Ah, nice. Okay. Oh, holy moly. Holy guacamole. That was a doozy. All right. You may be wondering, was this whole range intersection thing actually necessary? Let's comment it out and go to where we're doing our intersection. You might be thinking, oh, we could just do 2A here and grab the set intersection. Nada. Nope. No way. Because these ranges are so fat. They are really big ranges. And so by converting it to A, now we're trying to store it, and that just makes the entire thing sad. So we really do need this clever sort of intersection method. And yeah, I don't know. This was like definitely really tricky. I've got pages and pages of paper where I was drawing out ranges and trying to think through my head, like, how do you break this down and split this up? And then this sort of like dynamic programming business of collecting up the results and building backwards or whatever, or top down. I don't even know how you refer to this, but yeah, it's working. So we're going to call that a win. put it, yeah, stack it up in the win column, right? We've got a working solution here. So, whew, thanks so much for watching. Really appreciate your time and attention, and we'll see you in the next one.